Hello and welcome. In this lesson, we will talk about graphing quadratic relations by completing the square. It's going to be quite an interesting journey, and I hope you enjoy it. There are two forms of a quadratic function to start with: the standard form and the vertex form. The standard form is y equals ax squared plus bx plus c. As you see, all the terms in standard form are listed from highest to the lowest degree. The vertex form of a quadratic equation is y equals a x minus h squared plus k. Now, the vertex form of a quadratic equation comes in very handy in two different cases especially. Number one, when we are trying to graph the function, we can do that in two simple steps. And number two, when we determine the min or the maximum of a function, it's much easier when we get started from the vertex form of it. Now let's talk about each and every one of them. So, the vertex form helps us graph the function, quadratic function, because right away we can tell what the coordinates of the vertex are. So this would be the h and the k, which are the x and the y coordinates of the vertex. And once we identify the x and the y of the vertex, which is simply a point, then we apply the step pattern. Remember that the step pattern in any quadratic function or relation is 1a, 3a, 5a, and you know that you can continue on forever, 7a, and so on, all the odd numbers multiplied by a. When we graph the parabola, we also say that we need to go on both sides of the vertex. So we have to apply this pattern from both sides of the vertex. So I'm going to go over this one more time just to make sure that everyone understands this. So what that means is we start from the vertex and we go over 1, and then we follow the step pattern, which is 1a, over 1, and then we go up 3, we stop there. Over 1, we go higher, up 5. Now, wherever we have landed on, we have to mark a point. So we're going to say over 1 up 1, it's a point. Over 1 up 3, it's a point. Over 1 up 5, that's another point here. Now, when we say that we have to apply it from both sides of the vertex, so it means that here is the vertex, and I'm going to mark this actually by the letters H and K, and we just apply the step pattern from one side of the vertex. To apply it from the other side of the vertex, then we have to go one more time and apply the step pattern 1 through 5 from the other side or the negative. So we go over 1, up 1, over 1, up 3, over 1, up 5. And whenever we land on a point after we have moved over and up, we are going to plot a point. And when we connected those points, we were able to draw the graph of a parabola. Sorry about the mess in here. Hope this made sense though, and it helped us understand how to draw the parabola quickly. So this is the number one thing that the vertex form comes in very handy. The next one is when we use or when we solve application questions. Very often in application questions, we are asked to find the minimum or the maximum value of a function because it might represent some unknown quantities that we have an interest in. So we all know that a parabola can have a minimum when it opens up, or it can have a lowest point, or it can have a maximum when it opens down, which means that we have a highest point on a parabola. So we are able to mark the highest point. In this case, we say the parabola has a maximum. Okay? So we are going to say that to find the minimum or the maximum point on the parabola, we can simply use the equation in vertex form. Now remember that the height of the point, so how far up is or how far down is, depends on the y coordinate at that particular point that marks the min or the max. So we are going to say that the max or the minimum of a point is the y-coordinate, which is indicated by the coefficient k at the vertex. And that happens when x equals h, because these two numbers will go together. Now, if a is positive, and that's when a is positive right here, then k, so the value of y equals k, will represent a minimum. Now, if a is negative, the parabola will up and down. It will have a highest point, and the highest point will equal the value of k. Again, doesn't matter if the vertex marks a min or a max, okay? And the value of the maximum will be the value of y at the vertex, or k. In today's lesson, we are going to learn how to convert the standard form into the vertex form. Because in an ideal world, we would have been given the vertex form anytime we solve a problem with quadratic, or that can be modeled by a quadratic equation. But not all the time we're going to have that luxury, and sometimes we will need to take the standard form and convert it to vertex form in order to find out where the maximum is, what the value of the maximum would be for the parabola, and for what x value would the maximum occur. So, in other words, we're going to say that we are going to learn how to convert an equation from standard form, meaning y equals ax squared plus bx plus c, into vertex form, y equals ax minus h squared plus k. And this is where the new lesson kind of starts in here. It's quite an interesting process, and I have written up all the steps in here, but it's better that I explain them as we move along with the examples. So here goes our first example. Y equals x squared minus 6x plus 4. Now, I'm going to read step 1. Step 1 says, group the first two terms, the term that has an x squared and the term that has an x in it. So I'll group them. Here I am. I've grouped x squared and negative 6x. Step 1, done. Next step says, factor out a from the two terms grouped. So I'm looking at the two terms that I've grouped in here, and I see that a, which is the coefficient of x squared, is 1. What that means is that I have nothing to factor out. So I'm going to move on to step 3. Use the terms inside the brackets to complete the square. And this is kind of new to me. And this is when I'm going to stop and I'm going to think very hard to better understand the meaning of it. So I have to use the two terms inside the brackets. So the two terms inside the brackets are x squared and negative 6x. I have to use those two in order to complete the square. So completing the square, it's kind of a new term for me. So what does that mean? To complete the square means this. And I'm going to give you an example aside from this. So suppose that you have a perfect square trinomial. So in a perfect square trinomial, we have a squared plus 2ab plus b squared. And sometimes you have a squared minus 2ab plus b squared. It means it's the same thing. The process is the same. Now, in this case, what we do is this. We treat the first two terms that we have highlighted here in green, so x squared and negative 6x, as the first two terms of this perfect square trinomial. So this whole thing is a perfect square trinomial, or for short, perfect square. And we treat x squared and negative 6x as a squared and 2ab. So when I look now at x squared minus 6x, just separately, so I'm going to extract it from that expression I have there. I would say that the value of a here must be x squared. And negative 6x actually must represent 2ab. So what I'm going to do is one adjustment first. I'm going to look at this as with a minus, because we know we have with a minus and with a plus perfect squares. So here we go. We're going to have a minus in here just to match it perfectly. And I'm going to think, if I want to write 6x as 2 times a times b, so that means that I have 2. I already figured out what a is, so the value of a in this case would be, so this a is x, right? So it's right here. So right here, I'm going to write the value of a. So the value of a is x, 2 times x. And now I have to think, okay, so I want to have, or I have to make up my negative 6x in here. And what I have is 2 and a. What should I multiply 2x with in order to get the term that I actually have? So we're thinking maybe you need to multiply it by number 3, because 2 times x times 3 would equal 6x. So therefore we're going to say that if I have x squared minus 6x, and if I wanted to add a term in here to make it a perfect square trinomial, because as I mentioned again, this is part of our perfect square trinomial, we are completing the square, which means we're missing a term in here, okay, that we want to add. I'm going to think, what number or what term do we have to add in here at the very last spot to make this a perfect square trinomial? So remember, perfect square is the first term squared minus twice the product of the first with the second plus the second term squared, right? So twice the product of the first with the second plus the second term squared. And we have actually seen, or we have discovered somehow in here, that our b value must be equal to 3. So we're going to say then we must add 3 squared to this equation. So to complete the square means that we take these two terms as the beginning of our perfect square. Remember, a perfect square has 3 terms. And then we figure out what number to add to make this a perfect square. And we just figured that number out. And we're going to say that we have now y equals x squared minus 6x plus 9. We have completed the square. Remember, we also have plus 4 in here. I'm going to close the brackets. And now we're thinking, okay, wait a second, because we added a number in here, but this wasn't in here, so we have changed the equation. Are we allowed to do that? The answer is no, we can't do that. So how do we fix this mistake? Quotation marks. Well, we're going to say if you add a stranger that wasn't there, subtract it in the meantime. So we're going to say, okay, let's fix this. So we completed the square by adding a 9. And now we're happy that we have a perfect square trinomial right here. Okay, this is a perfect square trinomial. But because we added something that wasn't there, we need to immediately subtract it, close the brackets, and then plus 4. Write the rest of the expression. Now, the green, the highlighted green expression is a perfect square. This one here shouldn't be inside the brackets, so we need to take it out. And so we will. So we have x squared minus 6x plus 9 inside the brackets. And we take negative 9 out. And number 4 is waiting for it, right? And they will become good friends in here because they are like terms. And The equation is x squared minus 6x plus 9, which in factored form is x minus 3 squared. It's a perfect square. It always ends up being some binomial squared. And negative 9 and 4 together will join and make a negative 5. Okay, now take another look at this equation. Is this vertex form? So we're going to say, well, it kind of looks like a vertex form. A is 1. Here is h of 3 and k of negative 5. Okay, if this felt a bit confusing, okay, nothing to worry, because understanding how to complete the square can be quite tedious and awkward in the meantime process. So we are going to take more examples and hopefully we'll understand it and become more familiar with it and understand it better. Okay, and they won't seem as unfriendly as they seem probably right now. So I want to actually take another example, but I want to take, and before I move on to example number 2, I want to do an example with you with a coefficient of 1. So what I'm going to do is I'm going to grab a new page in here, and I want to take another example so that we can kind of repeat the exact same process. The reason why is because this is a little bit more complicated than this, okay? So when we practice the same process more than once, it kind of starts making more sense. So let me get some new page in here. So I'm going to add a new page right here. I'll go back here, okay? I'm going to make up an example. And here we go. We are here at y equals x squared. I'm going to make this plus 10x and then minus, I don't know, I'll make it 4. Okay? Oh, wait, 4. We had a 4 before. So let's make it 6. Doesn't really matter. So remember step 1. Step 1, group the first two terms, the x squared and the 10x. Step 2, complete the square. So we have y equals, so completing the square means that we have x squared plus 10x, and we need to add something else and subtract that same something else, right? So that we won't mess things up and change the value of the equation. And then minus 6. And you know what? Let me just make these pink just because they were pink before. Okay. And now we're going to think, okay, how do I figure out that number here again? Remember that this needs to be in the form a squared plus 2ab plus b squared. That's the perfect square trinomial. We want to complete x squared plus 10x with one more term in here to make a perfect square trinomial. So let's discover what our numbers or terms are in here. So we have our a value is x. So our a value is x. Now, the next term is 10x, which means that we have 2 times the a value, which is x, right? That's the a value that we have. And then we have to think, okay, so what else have I multiplied 2x with that I got 10x? I know that I'm in a perfect square, right? So I'm going to say, well, I need to multiply here by a 5. So here goes a 5. So this 5 will tell us what the b value is. So which means that right here, I need to write the number 25. Okay? So why the number 25? Because I just discovered that b was 5 in there. And then subtract 25. And see how we ended up with a perfect square in here, trinomial? And we know what we're going to do with negative 25, right? But before I do that, I want to show you a short, simple trick that can help you complete the square much more quickly. So a quicker way to figure out b is this. So you see that the coefficient here is 10, right? Now when the coefficient is 10, you got the value of b 5. So you can tell that here we have half of coefficient equals b. And if you look at our example that we had before, so half of the coefficient 6 was our b value. And that's what always happens all the time, because you have a squared plus 2ab plus b squared. So your b value, right, is going with number 2, so 2b. So this number 10, knowing this is your a, this number 10 will carry double the value of b. So to find b, you just take the coefficient of x, divide by 2. Okay, so now we are going to go over, sorry, here, y equals, we are going to keep the perfect square trinomial. I always call this the good part of the expression. So we're going to keep the good stuff in, and we're going to take the rest of the stuff, this one here, out. Okay, because we want to write it in factored form. And the good stuff will always be in the factored form, something squared, right? So x right here. And then here is 25, square root of it, right? So that would be 5. And then the sign of between the terms will be the sign of the middle term. And the negative 25 will go outside the brackets, and it will join negative 6, which is waiting for it. And in a more simplified form, we'll have x plus 5 squared. Negative 25 minus 6 is negative 31. And here we go, vertex form again. And in this vertex form, we can tell now that the vertex is right at negative 5, negative 31. Further to this, we're going to say that this parabola, if we were to draw the graph of it, will be, or will have a minimum, because it opens up a equals 1 or positive. Now the vertex of negative 5, negative 31 means that the minimum value of the parabola will be negative 31, and the minimum will occur when x equals negative 5. So in other words, we say minimum equals negative 31 at x equals negative 5. Now I hope you're ready for a more challenging example. So let's move back to our worksheet. So we are going to go over the example number 2, 3x squared minus 12x plus 15. You probably notice a difference between the two examples here. The coefficient a is 1, the coefficient a is different than 1. Just like when we factored trinomials, when a different than 1, the process changed slightly. Actually, it became a lot more complicated than in here. The process of completing the square when a is different than 1 will actually be slightly different as well. Not a lot more different though. So let's have some hope. So here we are. I'm going to give myself more room in here. Step 1. Group the first two terms that have x squared and x in them. This is an easy step to do, so I like this. And the next thing that I want to do here is, well, read the question. Factor a from the two terms that you have grouped. So the a value is always the number before x squared. So I have to factor this out of both terms. Even if 3 wasn't a factor of 12, you have to take that out, okay? So here we go now. We're going to rewrite the equation with a factor. And in brackets, we still have, from 3x squared, we have x squared. And from negative 12x, we're going to have negative 4x. Now, number 15 is outside the brackets. It has no business or whatsoever with this factor, so it's all by itself. You only took out the greatest common, the coefficient a from both of them, okay? Now, next step, use the two terms inside the brackets. So where are the terms inside the brackets? Well, they're right here. these terms inside brackets, to complete the square. Okay, I kind of know how to do this now. So I'm going to go y equals 3. I'm going to write what I have first, which is x squared minus 4x. And I have to think of what number to add and in the meantime subtract in here so that I make a perfect square trinomial somewhere in here. Okay? I want to make this a perfect square trinomial. Now I know the trick. How? I know that if I want to figure out this term, the missing term in here, my a is x, so this must be double the x times that missing term. Or as I mentioned before in the previous example, the value of b will always be half of the coefficient of the of x. So you take this coefficient, always take this coefficient, you divide it by 2, and then you square it. So 4 divided by 2 is 2, you square it 4, which means that here we must add a 4 and subtract a 4. So we'll add the 4 and we'll subtract the 4. Now number 15 is outside the pink bracket, so it's going to stay there, just waiting. Now in the next step, we're going to think, okay, here we are. We have 3. That's a factor. And we have x squared minus 4x plus 4, which we want to keep together as one unit because it's a perfect square. We want to factor that or write it as a binomial squared. But then we have this negative 4 that is inside the brackets that shouldn't sit in here, because if it sits here, we won't be able to write this in factored form. So we need to take this out. Now, this is how the game changes here when a is different than 1. When you take out negative 4, you must remember that, okay, listen carefully. This negative 4 is inside the brackets, and everything that's inside the brackets, the pink ones, has a coefficient. This coefficient applies to every term inside the brackets. So what that means is, you decide to take this out, you gotta multiply it by the coefficient 3 here. If you remember this step, then I would say that you will find completing the square very easy from now on. So we have plus 3 times negative 4, okay, and then we have plus 15 here. So now the equation is y equals 3. X squared minus 4x minus 4 now is, or can be factored as x minus 2 squared. And now the last terms here, the constants, they will get together. They're all like terms. And we'll make negative 12 plus 15 a positive 3. And here goes the vertex form. And we're going to say that the vertex is at positive 2, positive 3. The graph will have a minimum. That's because the parabola opens up. The minimum will be 3, and it will happen at x equals 2. Okay? So, in the next example, it's your turn to try. It's a little bit more complicated than the previous ones for one single reason, that the coefficient is very big. Okay? But the process is the same, so don't be afraid to try something new. Okay? You can do this because you know the principles of it. I'm going to get you started, and I really want you to finish this on your own. So again, group the first 2 terms. Then y equals negative 12. Take out the negative 12, which is a coefficient of x squared. X squared. Negative 24 becomes 2, close brackets, minus 31. Complete the square. To complete the square means that you still have your y equals negative 12. And then we go x squared plus 2x. We gotta add a number and subtract that same number, close brackets, minus 31. And then the number that you need in the empty spots in here will come, or you figure it out from the coefficient of x. So this coefficient of x is 2. Remember what we did with this. We divided by 2 and we square it. So this green stuff has to repeat all the time. So that would equal 1 squared, or 1, which means that you must add a 1 and subtract a 1 here. So next step, y equals negative 12. X squared plus 2x plus 1 will be the good part, or the perfect square trinomial part, this one here. And the negative 1 here has to come outside. Remember, this one will have a coefficient, so negative 1 must be multiplied by negative 12 when we take it outside of the brackets. So we're going to say that we have a negative 1 multiplied by negative 12, and then minus 31. So y equals negative 12. The factor form is x plus 1 squared. And 12 minus 31 equals, let me think very hard here. So 12 minus 31 will be 29, okay? Negatives. 19 negatives. Goodness. Alrighty then. So the coordinates of the vertex, we're going to say negative 1, negative 19. Would the function have a min or a max? We're going to say it will have a big maximum, actually. It has a maximum, and that's because a is negative. So a is negative 12, right? So what is the value of the maximum? Remember, it's always going to be the y value of the vertex. So we're going to say it has a maximum of negative 19. And it happens at x equals negative 1 because the two numbers go together. This is it for today. I know this is probably a long lesson, but I hope that I brought enough examples and enough explanations for you to thoroughly understand it.